For decades, the power grid was a one-way street. You drew electricity, used it, and paid the bill. Today, homes generate their own electricity, sending power back as often as they pull it in. This dual role requires a new vocabulary. When you combine a traditional consumer with an active producer, you get what the industry calls a prosumer. A prosumer utilizes local technology to create power directly on their property, applying that energy immediately to their own daily needs. You see this happening everywhere: rooftop solar panels on homes, solar-powered water pumps in fields, and small-scale wind turbines. By producing electricity at the source, everyday people take direct control of their energy supply, keeping more money in their pockets instead of sending it to massive utility companies. This shift is part of a larger system called Decentralized Energy Generation. Looking at this network diagram, the core concept is clear. Instead of relying on distant megaplants, electricity is produced locally, directly connected to the homes and businesses that use it. This local generation usually falls into three main categories: solar rooftop systems harnessing sunlight, wind turbines capturing local breezes, and biomass or microhydro setups utilizing agricultural waste or water flow. Look at this physical layout. Centralized power plants sit miles away, but decentralized generation happens right where power is needed. This proximity enables a two-way exchange. Homes can draw power or feed surplus back. Avoiding long, high-voltage lines slashes transmission losses and boosts self-reliance. Generating electricity exactly where it is consumed completely eliminates the massive energy waste inherent in long-distance electrical transmission. Let's walk through a home system's technical steps. First, solar panels collect sunlight and convert it into direct current, or DC. This raw DC is then routed through an inverter, converting it into usable alternating current, or AC. This freshly converted AC power goes to the home's electrical panel, instantly powering active appliances. If the panels generate more than the house needs, the surplus power is exported straight out to the main grid. This two-way flow is tracked by a system called net metering. As you can see by the directional arrows on this diagram, the meter constantly calculates the difference between the power you import at night and the surplus you export during the day. By balancing what you give against what you take, net metering acts as the financial brain, effectively turning the public grid into a giant free battery for the prosumer. Expanding this model across a region creates immediate benefits. It directly reduces environmental pollution by cutting reliance on fossil fuels, and it drastically improves the reliability of the electricity supply, particularly in rural areas prone to load shedding. There are realistic hurdles. Financially, initial setup costs are high, driven by battery storage and inverter prices. Technically, solar relies on clear weather and requires routine physical maintenance, like regular panel cleaning, to maintain peak production. For electricians, safety is strict. Due to dual-source power, you must achieve isolation by disconnecting both grid and solar supplies before touching wiring. Proper earthing prevents fatal faults, and wearing insulated gloves and safety shoes is an absolute mandatory requirement. In a traditional home, shutting the main breaker killed the power, but in a prosumer home, electricity arrives from both the roof and the street simultaneously. Technicians must adapt their safety practices to match the dangerous reality of a live, two-way grid. To recap our lesson, we've covered four main pillars: the transition of customers into prosumers, the mechanics of decentralized generation, the financial accounting of net metering, and the future career opportunities these create. Let's check your understanding. What is the specific term for a customer who produces their own electricity and consumes it themselves? They are a prosumer. Next question: what exact type of electricity is generated directly by solar panels? Solar panels collect sunlight to create direct current, or DC power. Finally, what device is used to measure both the imported grid electricity and the exported solar surplus? That accounting is handled by the net meter. Mastering how electricity flows in two directions is an essential first step. By understanding these decentralized systems, you advance from a traditional wireman to a highly skilled smart energy technician.